So in today's video, we are going to talk about vectors, a whole new topic, and we're diving deeper into multivariable calculus. But this is just an introductory video to vectors. So we'll do it step by step, and I'll try to introduce the topics at the same time. So for our first question, we want to find the vector. Basically, a vector is consisted of various points. There's 3D and there's 2D. In this case, we're given P and Q, so there's only 2 points. So if you think about it, think back to what we learned in the past. For example, let's say this is 1 and this is 5, 10, 15, 20. And if we were to plot these 2 points, right, P would be around, okay, let me just expand that. P would be around like here somewhere, and then Q would be around here, and then we have a line here, right? So vector is basically kind of like a line. But the direction matters because here we have P, Q, so it's going to the direction from P to Q. So we have to put an arrow saying that the vector is pointing towards Q. And so when we're given 2 points, what we want to do is subtract the end point from the start point. So in this case, PQ would be the end point. So we have for our first x value, our endpoint is q, so it's 0 minus 1, and then 17 minus negative 7. And then vector, one thing we do is using this sort of symbol, I guess triangular brackets. So that represents a vector, and then we simply simplify our answer, which is in this case negative 1, 24. So it's kind of like basically finding the slope, but in this case, it's basically finding a simple vector from 2 points. So there you have it. For our second question, we're trying to find which of the following vector is parallel to V. When we find something that's parallel to a vector, we have something called a scalar multiple. So let's say I have let's just say 1, 2, 3. And then I have a new point, and I multiply this by 2, for example, I get this, this. And these 2 vectors, this is what we call parallel because there's a multiple of 2. So you can kind of see where this is going. In order to find what's parallel to V, from this list, what we want to try to do is find if there's any number, let's call it C, multiplied, we'll get the same answer. So let's try for the first one. So basically we want something in front, I call it C just as any variable, right, equals to 4, 8, and 12. And in this case, let's see what number goes into 2. What number times 2 gets 4? And if that same number times 4 also get 8, and if that same number times 6 will get 12, right? Let's see what number. Let's try 2, for example. So in this case, I have 2 times 2, 4, 6. And then we get 4. So we basically just expanded 4, 8, and 12. And let's see. Oh, they are the same. So that means this is parallel to V, and it is also the same direction because the sign is exactly the same. So there you have it. We have the first one is a scalar multiple of 2, which makes it parallel because it's the same. Now let's take a look at the second one. So again, we want to find out what number multiplies by all these numbers. We'll get the same vector 4, 8, and 12. And what I usually do when it's slightly more complicated is I can just basically try the first one, because if the first one matches, then we check if the second one also matches, and if they don't match, then there's no point in continuing. So let's say for the first one, we want the first one to be equal to 4, so basically negative 1 times C equals to 4. that means that c has to be -4. So let's try that. If c is -4 and we multiply by that, let's see if it's the same. So for our first value, we get the same, 4. For our second value, it's -2 times -4, which is 8. So far so good. And then this last one, 4 times 3, is -12. Well, we see that the vector that we're given is 4, 8, and 12. In this case, it's the same except we got a negative number. And because there's a negative number, then it is not parallel. So unfortunately, this is not parallel. So we can't say that is parallel because even though the numbers are the same, if one of the sign is different, then it's not parallel. But if, let's say, all the signs, if we get something like this, then that would be parallel, but basically opposite direction. But you basically can't have one value in the vector that is negative, and then the rest is positive. So for our third one, let's take a look. Again, we want to take a look a scalar multiple that will give us the same vector. So let's take a look. Again, I can use the first method, try to match the first one. So I have -7c. I want it to be equal to the first value, which is 4. And I get 4/7, -4/7. And then now let's try using this and solve for the other values. So I have -14 times -4/7, and let's see if it's equal to 8. So to do that, I basically just multiply that, and so basically 14 times 4, you get 16, and that is 56. Negative becomes positive, so 56/7, and that is indeed equal to 8. So far it's good. The first value multiplied by -4/7 is equal to 4. The second value multiplied by -4/7 is equal to 8. So far so good. Let's take a look at our last one. We have -21 times the same value, -4/7, and let's see if this is equal to 12. So in this case, to make things easier, I could just cancel out the 7, that's 1, and that's 3. So -3 times -4 is 12. And hey, we got all our answers the same. And so our answer is yes, it is parallel. This is parallel. But notice that it's all negative numbers, and so therefore this is parallel, but it is the opposite direction. Last but not least, let's take a look at the last one. We have 6, 10, and 4. So for our last one, again, we want to match the first one with our original value, and we get 4/6, which is 2/3. Let's try to put that into the second one. So 10 times 2/3. Let's see if it's equal to 8. So we have 10 times 2, which is 20. 20 divided by 3. Is that 8? No. So unfortunately, at this point, I don't even have to continue. I just know that it is not even parallel. So there you have it. That is how you check whether vectors are parallel. And to see if they're in the same direction, it's just basically they all have to have the same sign. If they're all negative, then opposite direction. If same sign, same positive sign, then it will be the same direction. Last but not least, we want to draw geometrically which vector is v plus w and v minus w. So when it comes to adding things, it's very simple. In this case, we have v and w, and they start at the same point. Whenever we want to add two values together, the first value always remains the same. We can keep the v as the same, or maybe if it's better, I could just copy this so that it's exactly the same. So V remains the same, and when I add W, I want that W, instead of going like this, I want to basically shift it so that it's the same. Like, see, it's parallel, but basically it starts at a different point. So W started here, now we want W to start at the tip of V, but also parallel. So now that we have that, the line in between those two is V plus W. So there you have it. That is how you add V plus W. For V minus W, it's slightly more complicated. So let me just copy this entire diagram here. Basically, when we do V minus W, the V again remains the same, but the W is negative. So we can think of it as V plus negative W. And we want to figure out what does negative W look like. So negative W, we know that the original W looks like this. Negative just means the opposite direction. So instead of pointing this way, it's now pointing the other way. So it would look something like this. Okay, this is gone. So that's negative W. And now we want to add these two together. So to do that, remember, I have to connect this to the tip of V, right? So let me just write this so that it's more clear. So basically I just shifted it so that it starts at the tip of V, and then to add them, I just basically connect them. So that's V plus negative W, which is also the same as V minus W. And so there you have it. That is how you do it geometrically. It can be a bit confusing, but the main goal is to basically connect a vector to the tip of another vector, and to connect the lines together. That's how you get addition. And for subtraction, you basically do the same. You add it, but you flip the negative vector and then do the same as what you did before, connect them together, and that's how you subtract vectors geometrically. And that's how you do it, some introductory to vectors. I hope you guys find this video helpful, and see you guys next time. Bye!